All right. Good afternoon, everybody. Thanks for coming to our session. Actually was a good segue from the previous talk, talking about value prioritization. We want to talk about three things today. One is how to link that value creation and articulate that, why we think data products and product thinking is important for data and AI, and then how to organize the teams to deliver that at scale. So my name is Danilo. I am the Global Head of AI Platforms and Engineering at Thoughtworks. I've been here for over 16 years, and I've been involved in the space doing engineering for machine learning, and I wrote some of the articles around our approach for continuous delivery for machine learning.
Hi, I'm excuse me. I'm Art. I've been with Thoughtworks slightly shorter than Danilo. I have 5 years of practitioner experience as a machine learning engineer, mostly specializing in dynamic pricing and MLOps.
So very briefly, if you haven't heard about us, Thoughtworks is a global technology consulting company. We are very famous for bringing agile approaches to software, and we brought that into data and AI as well. And we help our clients all the way from their strategy, designing their solution, implementing with them, and evolving that over time. And we've got global presence, as you can see, multiple countries across the world. Specifically in data and AI, there are three kind of types of services that we offer. We help our clients with strategy and governance, defining that roadmap and how they're going to deliver value. We do a lot of work with modernizing their platforms to be able to deploy this and do this at scale. And obviously, applied AI and analytics engineering to actually build the solutions that will bring those things to life. And we'll quickly jump into the first area around value articulation, because with all the hype around AI, what we've seen is every board is asking the top executives, what's going to be our AI strategy? What should we do to unlock value? And this is one of the key things first. So defining that value is very important to justify all the investments that you're going to do. So we see a lot of clients investing a lot, what we call this the 3 phases of the cycle of intelligence: building the infrastructure, gathering the data, even like building reports or insights, but not as much time defining what is important, which is that last mile. Where is that going to drive better decisions, and how are we going to put that into action? So it's pretty important when we think about strategy to answer that first, like how are we going to solve that last mile? Who is going to be making those decisions? Do we want to automate? Do we want people to make those decisions? And then we figure out how we get the right data in place to do it. So it's very important to close that cycle, because once you take a decision and you take action, you can gather more data and you can make better decisions going forward.
All right. So what we've gone ahead is we've done a survey with business leaders, asking them questions about data strategy. And if you want to read the full report, then you can scan this QR code here, but I'll just quickly walk you through the main findings. What we've actually seen is that while most businesses do have a business strategy in place, a data strategy in place, it is not completely aligned with their overall business strategy. Only 39% of businesses answered that their data strategy is in complete alignment with their business goals. In addition, we see that a lot of businesses' data strategy is not closely connected to their AI strategy. And we especially see a business distinction here, a big distinction here between small and big companies. So while big companies do focus a lot more on their data strategy for AI, small businesses are more concerned about how do I actually make better decisions with data instead of focusing on AI.
So how do we do this when we're working with the client? So we think it's important to first start with the process. Like, what are we trying to improve? You're already doing something, whether you're a B2B or B2C organization, you can map your process. If it's an end customer, use service blueprint or whatever mechanism. Or if it's internal processes, you can map the process, the value stream. And you identify in that process, where are the decision points? Who is making decisions? What are the potential that we can improve, that we can automate, so that we can do faster? And not only that, it's important to think as well, like, what do we want the future to look like? Who's going to be making decisions? Like, are we trying to really automate the decision and remove the human completely? Are we still supporting human decision making, in which case we might need to build a dashboard? Or are we doing a collaborative, augmented approach, right? We're actually augmenting the humans with some AI capacity that together they'll make a better decision. And how do we connect that back into that process is how we can articulate where we're going to improve things and move the needle. So the first piece is value. The second piece is product thinking. And I'll give you an example describing a data architecture, and then I will ask you to think about if you can guess which kind of organization this is, what industry do they operate. So this company has lots of data sources. They've got their enterprise systems, they've got their finance systems, customer relationship systems. They ingest data through streaming, through batch, into some kind of data lake or some kind of storage. They process that with different pipelines. They have different quality levels of data, bronze, silver, gold, and then eventually they serve that data through a data warehouse or a data mart for different consumers of data. So it could be a dashboard, it could be a report, it could be for machine learning or applications. So who's got architecture similar to this, at least at a high level here? Right, everybody. So this is talking about the technical architecture. It's very hard to guess what the business is because I'm not talking business. And the reason why data product is important is because I'm going to describe another example from a client that we worked with. And this time I'm going to talk in language of data products. So one data product they have is content. That's their business. They create, they produce content, and they manage that. They call it supply chain because they have to manage who is allowed to distribute the content, how do they manage rights for where the content is being shown. And on the other end, their customers are actually viewers because people are watching their content. So they have systems that manage who their viewers are. But also, they track what are they watching. So there's viewing activity. People started watching a series. Maybe they stopped halfway. So all of that is important data. And in this case, we were working with the marketing team for the organization to help them bring that data together to create audiences. And what they're trying to do is to activate those audiences with marketing campaigns to get viewers to re-engage with content that they maybe haven't finished watching. So they're creating these audience segments. And you can see, like, I'm describing business, and you might not know exactly which client it is, but you can pretty much guess this is a company that works in the media entertainment sector. In this case, it was ITV. It's one of the large broadcasters in the UK that we worked together to develop something like this. But if we zoom in inside the data product, you will see the similar technical pieces, right? So you have input of data coming in, maybe through batch or ingestion. You will store that somewhere. We'll have pipelines that we're trying to process data to serve. And then we expose that in an output that might be used by other data products or might be used by end consumers. So the technology is still very similar, but the way I'm describing the architecture is a lot more business focused. And because we're in an AI company, it means we could have different flavors of AI of products in this architecture. So I could describe let's say, a traditional machine learning product where the input now is data from other data products. Inside here is my machine learning pipeline when I'm training my model. I might be doing maybe feature engineering, and maybe the features that I develop to train the model might be one type of output that might be used for training other models. But one important output is actually once I deploy the model in production, there's going to be some kind of inference endpoint that other systems or apps will use to actually consume this model in production. And I've described another one, Gen AI flavored. Let's say we're building a RAG-style architecture. This time the data coming in is your content that you're trying to index, and then you pre-process maybe that you load into, I don't know, either vector store or a graph database. And then your endpoint is going to be the user query API that your user is interacting and asking questions. Then you go through, the retrieval phase, maybe to figure out which model am I going to query, how do I write that query to fetch it from the right knowledge base. Maybe you return a bunch of documents that I have to re-rank. And then you've got your generation phase where I add those relevant documents into my prompt that goes to the LLM to produce the final output to the user. So you can see there's very different technical components inside the architecture, but we can still think of the data products as the building block for the architecture. So if I go back to that process, if I identify those decision points and the last mile where we want to change things, now I can start mapping, okay, which products am I going to build to help improve those decisions? Is it going to be a dashboard for the human to make a decision? Am I going to put a model that will automate that decision altogether? And then to train those models, I'm going to need other types of data products to feed that model or to train the model or to feed the dashboard. And the way that we deliver this, we can even slice things even thinner, because I don't have to solve the whole process all at once. We can actually take a use case to pick, maybe I'll try to improve 2 of these decisions and deliver that use case. And then once that's done, I'll try to improve the next thing and the next thing, and then I build more and more data products over time. So to make this a bit more concrete, when we were working at ITV, in that case, the process was to execute and run those marketing campaigns. So the types of decisions that they were asking was, which content should I look at? Which viewer? Is this audience big enough that it's worth for me to run a marketing campaign for them to re-engage? And then based on that, we mapped those data products that I talked about before. Some of them were more power to that decision making, and some of them was more kind of core data that was needed to feed that. And in their case, the last mile was a system that they were putting in place for the marketing team on the customer data platform. So in that system, they can create the audiences, they can manage the campaigns, that they can execute the campaigns. So by doing this work with them, we achieved the first MVP in production in 8 months. And we won this Data IQ Awards because we were able to basically put all the data in the power of the marketing folks, where they could create and address campaigns in 3 minutes versus something that could take up to 3 months before because of all the different teams and the different data movement that they have to manage.
Awesome. So I'd like to talk with you about how do you actually organize to execute the strategy. And to do that, we're going to talk a bit about team topologies. And we're going to take this as an example. So this organization has been adopting AI, let's say, in the past 10 years. And every time that they wanted to adopt a new AI use case, they've gone ahead and spun up new AI teams. And the nice thing about this is that these teams truly own the whole solution end to end, right? So they not only manage the data science, they also do the data transformations, but they also make sure that there's an endpoint and that there's a nice feedback loop to make sure that the data scientists are improving the right thing at the end of the day. But as data science products mature, so does the stack that this team has to manage. And what happens in effect is that your data scientists that used to work on only, let's say, nice notebooks with experiments end up having to manage the entire stack of this solution. So what we see in organizations that have their teams in this way is that these teams, instead of working on the actual interesting work that they find, end up managing all of this infrastructure around their data science solution. And at the end of the day, that is not something that these teams want to do, because a lot of this work can actually be shared amongst the teams, right? So let's go to the other side of the spectrum. And this is another extreme. So imagine that you have a company that has a central data science domain. So this is a team that basically picks up all of the different AI use cases that come in. In 2019, they wanted to do price forecasting, then stock optimizations, and then now, like everybody, they're doing LLM use cases, and every time that they want to pick up a new use case, they can just add new people to this team. And this is very nice because that means that there's one central team that has all the data science knowledge. There's true experts in this team. They really know what they're doing. And yeah, it's easy to pick up new POCs because of that, because you don't have to spin up an entire new team every time you want to do something new, right? But the downside of this team, and what happens in practice, we see that this team can become quite disconnected from the business case that they're trying to solve. What that means is that it's very difficult to set up a feedback loop as a data scientist if you're not a domain expert on the actual use case that you're trying to solve, right? Because at the end of the day, what AI products have to do is solve some sort of business problem. And there are business metrics that are influenced by this AI product. And if you are a data scientist and you don't have enough information about the use case, it's very hard for you to set up this feedback loop. And in addition, we see that teams like this, the more use cases come in, the harder it becomes for the teams to actually manage all the different requirements for the use cases, right? So one use case might want to have something that, I don't know, does inference every week. Some use case might want to have something that does inference every day. And so you run into this problem of when everything is important, then nothing becomes important, right? It's very important to set priorities in this case. So this is a big risk for these types of teams. And what we've seen that works well in practice is, first of all, good governance and strategy for data and AI. And what does that mean? That means that you, on a strategic level, define what is important for me as an organization in terms of AI, which AI solutions are business critical to me and why. Because once you have that in place, this is something that you can translate into requirements for your data products or ML teams, let's say. And then these decentralized ML teams can leverage a central self-serve platform. And this platform is managed by a central ML team. And they produce shared infrastructure, shared templates, examples for the data scientists to use. And so really you have the best of both worlds in this case.
Cool. So just to summarize the 3 key themes we try to talk about, I guess, first of all, it's quite important to align data and AI with the business strategy. So we're not just building POCs that the business is not going to care about. And to really unlock value is to think about that, like what is the decision point, what is the last mile for these use cases. We talked about why we think product thinking is important for data and AI, for how you structure the architecture, but even how you think about the teams and what they own. And then finally, how to operate, how to structure the teams. We believe a decentralized model can help tackle that problem with the bottleneck of one team doing everything, but supported by a common platform that puts some of those standards, some of those templates in place, and it supports the governance process that you have as well. So I'm Danilo. This is my colleague Art. You can connect with us. If you don't have time to answer all the questions here, we are in our booth on the other side of the Expo Hall at B74, so you can come and talk to us afterwards as well. But I believe we have a little bit of time for maybe 1 or 2 questions. Thank you.
Thank you very much. We have time for 1 question, I think, from the audience. Do we have any questions, any burning questions out there? Please raise your hand if you do. Got any out there? Oh, we've got a lady in red top there.
One small question. So how do you establish the feedback loop between the centralized team and the decentralized platform team?
Yeah, good question. The way we think about the platform team, they are almost like building the platform as a product for those internal teams, right? So the same way you would have feedback loop, user feedback or user testing for the end products that you build, the platform should be managed in the same way. And the other key piece, I guess, just to highlight, we try to make it self-serve because that's how we unblock that bottleneck problem, right? Like if all the teams that need something need to ask the platform team to do something, then you still have the similar bottleneck problem. But think about like how we use some of the cloud infrastructure these days, right? Like I don't need to call the cloud provider to provision something for me. I can just call an API and self-serve, it will provision for me. So we're trying to build a platform like that where the capabilities are self-serve, and then the platform team owns that as a product, and they take that feedback from the product teams to evolve as it grows.
Okay, thank you. 1 more question. Just coming with the mic. Thank you.
Hi, I really like this self-service idea, but from this team, centralized team point of view, how to measure the success of such a self-service platform, in your opinion?
Yeah, I think there's a few ways. One is like look at the workload in terms of supporting those teams, like how easy is it to onboard new teams? How much time do you have to spend helping them or like fixing problems for different teams, right? Because once it's truly self-serve, this is why you can unlock the scale, and it should be something that you can manage with one team, right? Like if you feel the need to keep increasing capacity for the platform team because there's more and more demand, that's a sign that is not self-serve enough. But we're trying to create the right abstraction so that a team can actually manage the platform and evolve it over time. I don't know if you've got other suggestions.
No, I think that's right. And this platform is really meant to take on the tasks that are, like I showed this picture of, what you think your data science team is doing versus what your data science team is actually doing. It's really meant to take away all of these things that are pretty repetitive between use cases, let's say, And a good way to measure that is like actually look at your team topologist and see, okay, how many data engineers do I actually need to put this thing into production versus how many do I need before?
Thank you very much. Thank you very much, Danilo and Artiom. Let's give them a round of applause. Thank you.